And now we are here, inside the lab, so you can follow me inside the lab. So here we have the test rig, and the flow is coming from this channel. We have a 90 kilowatt compressor in the other room, so the flow is coming in here, and you can consider this as a small wind tunnel, in which here in the test section we can introduce the test object that we want to analyze. And well, we can also rotate the cascade, and in this way we vary the inflow angle. So for example, if this was the nominal angle, now we are at 30 degrees off. And here on the back side, inside we have a system for traversing aerodynamic probes that we use to measure the inlet and outlet conditions to the cascade. But if we come back here, this is the test object that we're going to test today. It's called Flutter module, and you can see that here we have a cascade of blades, low pressure turbine blades. You can see that the 5 central ones are instrumented, so we have small pressure channels, and we can measure the pressure distribution at the mid-span position. And also you can notice that here we have a system that we call mechanism for variable stiffness, that we can use to vary the stiffness of the blades, because the more the length, the free length of the spring, the lower will be the mechanical stiffness of the blades, and in turns the aerodynamic response. So if we take a closer look on this side, well, here we can see we have some potentiometers that we use to measure the displacement of the blades. A potentiometer is something like this, so it transforms a rotation of the blade into an electrical signal that we can read with the data acquisition system. So for example, now if I try to excite one of the blades, we should see on this monitor the displacement. So if I do like this, here you can see the response, and you can see that is decay. This is called the ring down test. So basically this is the structural response of the blade when we have no flow in the cascade. And also, as I said before, we can read the pressure distribution, because we have pressure transducers which are mounted inside this box. We have 15 pressure tabs per each blade, and a pressure transducer looks something like this. This is a differential pressure transducer. So we have some reference pressure, and then we measure the pressure with respect to that reference. And again, we get an electrical signal that we can read with the data acquisition system. Good. So now we can introduce this test object inside the wind tunnel, and then we will be able to test it. Before doing that, I need to bring the test rig to the nominal inlet condition. So to do that, I set the inlet angle to 0 degrees. So you can see now the cascade is rotating. Perfect, and now I can introduce the test object. perfect. We can remove now this table, and that's it. And now we can start the flow. So I come here, and let's see. And now here on the display, you will see this is the pressure distribution on the blades. Now of course we're running the cascade at very low speed, but when we increase you will see the loading that increases. But I need to wear my headphones now.